Hey guys, welcome back to lesson 2.5 about special trig limits. If you stuck around until the end of the last video, we proved a special trig limit that we're about to use again right here. So there's going to be two that we're going to talk about today. So let's get cooking talking about special trig limits. So first we're going to find this limit. We're going to find the limit as x approaches 0 of 1 minus cosine of x over x. So we noticed direct substitution isn't going to work, can't divide by 0. So I'm going to manipulate 1 minus cosine of x over x using the conjugate method. So the reason I chose the conjugate method is I see 1 minus cosine x here. I notice if I multiply this by 1 plus cosine of x, I'll get 1 minus cosine squared of x, which is sine squared of x, which could be helpful because last time we proved the limit of sine of x over x. So I'm going to multiply this by 1 plus cosine of x over 1 plus cosine of x. So what I'm left with is 1 minus cosine squared of x over x times 1 plus cosine of x. All right, so now the reason this is helpful is now I'm looking at the limit as x approaches 0. If I remember from my trig identities, 1 minus cosine squared of x is the same thing as sine squared of x. So I've got sine squared of x over x times 1 plus cosine of x. So I can break this up into two separate limits. I can look at this as the limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of sine of x over 1 plus cosine of x. And now this is helpful because I can actually do both of these limits. We proved this limit last time. This limit is 1 times this limit, sine of 0 is 0, but cosine of 0 is 1. So this is 1 times 0 over 2, which is 1 times 0, which is equal to 0. So this limit as x approaches 0 of 1 minus cosine of x over x is equal to 0. So this is our second special trig limit. So we have two special trig limits. They are the limit as x approaches 0 of sine of x over x, which is equal to 1, and then the limit as x approaches 0 of 1 minus cosine of x over x, which is equal to 0. So I'm about to move on to the next page, but know these limits. Don't forget them. They're going to be very helpful with solving some different looking kind of trig functions. Limits of different kind of trig functions. So here's an example. I have sine of 12x over 4x. So if I notice here, 12x, 4x, not the same thing. But what I could do is I could take sine of 12x over 4x and multiply it by 3 over 3. That's a 3. 3 over 3, which again is legal to do because that's 1. So this is 3 sine 12x over 12x. Now, if I notice, I have the same thing here as I do down there. So now I can say the limit as x approaches 0 of 3 sine 12x over 12x. This is the same as 3 times the limit as x approaches 0 of sine of 12x over 12x. Now that I have the same input here and here, I notice that this limit is just 1. So this is 3 times 1, which is just 3. So what ends up happening is if you were to actually simplify out this way, if you notice 12 divided by 4 is 3, it happens to be true that you can divide this by this to give you the limit. And that works because of this process right here of actually multiplying it out so that we have the same input. We have the same value in the denominators we have as the input of the sine function. So we're going to do one last trig limit. We're going to find the limit of this. And this is an example of something that looks complicated, but when you actually try to do it, is fairly straightforward. So the first thing that I want to do is I want to look at this and notice this says cosecant of x. Cosecant of x is the same thing as 1 over sine of x. So this sine squared of x, I have sine squared of x divided by sine of x. So this is really just the limit as x approaches 0 of 1 minus cosine of x times sine of x over x squared. I can break this up into two separate limits. This is the limit as x approaches 0 of 1 minus cosine of x over x times the limit as x approaches 0 of sine of x over x, which now I know these two limits. This is one of my special trig limits. That limit is 0 times this limit is 1. So the limit of this whole thing would just be 0. Even though direct substitution didn't work, because when I plugged in, I divide by 0, I simplify and I notice I can break it up into my two special trig limits. So that's it for today. Today we talked about special trig limits and how to find some limits using those two special values. So I hope you guys took some notes. If you have any questions, bring them to class. I hope to see you again soon. Have a great day.